in the notes above, what this says is that Z1 is R cos of the angle plus I sine of the angle. Okay, that was some of the notes we came above, and we did that. We had a look at that yesterday, talking about the Argand diagram. Remember the Argand diagram? Shush, please. Shush. Talk about that there. Okay, this is going to be my angle. That's my opposite. That's my adjacent. That's my hypotenuse. So this value here, stop. O is going to have the opposite. So is going to be where my I sits. Okay. So we did that quickly yesterday. So this here can be written as 2 times the cos of 60 plus the I sine of 60. Okay? Now cos of 60 is a half, and the sine of 60 is root 3 over 2. Alright? Someone put that into the calculator, please. So that's going to be 2 lots of a half plus root 3 over 2. Root 3 over 2. Yep. Yep, spot on I. Are we happy with that? And then what we're going to do now is multiply each of these by the vector, the modulus. I did that in my calculator, and it gave me 0.877, 0.866, and 0.866 times 2 should be root 3. Pretty sure it is anyway. That gives me 1 plus root 3i. Does that make sense? Is that pretty happy with that? So it's very similar to what you were just doing. Well, it is when you think about it, because all you're doing now is going, this one here, Z2 is just 2, the cos of pi over 2, plus the I sine of pi over 2, and that's where you're doing. Now, is that degrees or radians? Radians, okay, so the cos of 90 is 0, yep, good. The sine of 90 is 1. So now we're just left with 2i. If I asked you to draw that on an Argand diagram, what are you going to do? Here's my Argand diagram. There's my complex number of 2i. Does that make sense? Is it actually probably easier than the other one? Is this one a little bit trickier? Try that one there. Okay, so there we go. That's my working, and I'm asking now, are you happy with that? Yeah. And some of you guys are saying yes, some of you are saying... Is anyone saying no?
Are we supposed to be able to recognize it as just the square root of it?
Yes. Well, so this would be 2 lots of 1 over root 2. 2 is root 2 times root 2, isn't it? So this, I've expanded this bracket here.
Yeah, I've
done that. I've done 2 times 1 over root 2.
What happens if you don't even do that first step?
We need to do that
you
first
do 1
step.
over root 2. Yes.
I know that a 45 degree triangle is 1 root 2. It's on your formula sheets.
Does it matter if
And 4 5 pi over 4 is just 45 degrees plus 90 degrees. Isn't it?
So do you have to have it as root 2?
No. My question is, gentlemen, this may or may not be right. The class about to finish. I need you guys to recognise that that's wrong. Stop. Why is that wrong? Stop. Why is that wrong? Because of the plus or minus.
Where's the 2?
Well, isn't it 2 of, yeah, how do you...
What quadrant is that in? What quadrant is that complex number in? Which one? 1, 2, 3, 4. 1, 2, 3, 4. Where is negative 5, 4 and 4? Is it?
3.
3, isn't it?
You said 5, 5, 4 is 45 degrees.
It's a negative cot, then it's a negative. So
Didn't you just say
Say again?
Didn't you just say that 5 pi over 4 is 45 degrees?
Did I?
Yeah, that's what you just said.
It's 45 degrees.
Plus 9, 45 degrees.
Plus 90.
Plus 9.
Is it? Or is it 180 plus 90?
It'll be 180 plus 9.
It'll be 180 plus 90. So what quadrant is it in?
3.
It's actually up in 2, isn't it? That there is not actually a proper polar number, is it? Polar form number. That's probably what I was referring to.
Nice, man.